Hi everyone, my name is Calvin, and welcome to the first episode in my series on unsupervised learning. In this video, we're going to build our very first unsupervised model using k-means clustering. Don't worry if you're brand new. I'll walk you through everything step by step, from loading the data to visualizing the results. By the end, you'll understand what k-means is doing, how to decide how many clusters to use, and even how the algorithm evolves over time. If you'd like to follow along, I've put all the code, notebook, and instructions in my GitHub repository. The link is in the description. You can clone it and run the notebook yourself, or you can just watch and learn. K-means is one of the simplest and most popular algorithms in machine learning for finding patterns in data. Instead of needing labels or answers ahead of time, k-means looks at your data and tries to group similar points together. You tell it how many groups you want, and it does this by guessing where the centers of those groups are, then moving them around until each point is in the group it best belongs to. Think of it like sorting people at a party into circles, based on who they're standing closest to. Over a few rounds, the circles rearrange until everyone has found the group that fits best. Before we get started with clustering, let's import the libraries we'll be using. NumPy is the backbone for fast numerical operations in Python. Anytime we need to work with arrays or mathematical calculations, NumPy is under the hood. Pandas gives us data frames, which makes it really easy to load, clean, and manipulate tabular data like the customer dataset we're using here. Matplotlib, specifically pyplot, lets us plot charts and scatter plots so we can visualize both our raw data and the clusters that k-means finds. From scikit-learn, which is the main machine learning library in Python, we're going to import three key tools. That being standard scaler, which puts all of our features on the same scale. K-means, which is the clustering algorithm we're learning about. And silhouette score, which is a way to measure how good our clustering is. To get started, we'll load our dependencies. We will now load the mall customers dataset, the dataset that we are using for our unsupervised learning algorithm, from Kaggle. This dataset contains demographic and spending information about customers. We'll focus on both annual income and spending score for clustering. Let's load our data. As you can see, we have 5 columns, that being customer ID, gender, age, annual income, and spending score. Before we run k-means, let's take a quick look at the data. Here, I'm going to make a scatter plot with annual income on the x-axis and spending score on the y-axis. Each point will represent one customer. We will use pandas to plot this directly from the data frame. Then we'll add a title so it's clear what we're looking at. Finally, we'll display the plot. When you look at the chart, you can already start to see natural groups forming. For example, some customers have high income and high spending, which you can see in this cluster right here. Others have high income but very low spending, as you can see down here. And there are clusters in the middle as well, as you can see here. This is exactly the type of structure that k-means is designed to capture and formalize for us. Now, we're going to prepare our data for clustering. Out of all the columns in the dataset, as you might recall, I'm selecting just 2, that being annual income and spending score. These are the features we want to cluster on because they give us a simple 2-dimensional view of our customers. Next, I'm using something called a standard scaler. K-means works by measuring distances between points, and if one feature has bigger numbers than another, it can throw things off. For example, annual income can range into the hundreds of thousands, while spending scores only go from 1 to 100. If we left them like that, the algorithm would mostly focus on income and ignore spending. To fix this, we can scale both features so they're on the same scale, meaning they'll each have a mean of 0 and a standard deviation of 1. This way, both income and spending contribute equally when k-means calculates distances and forms clusters. Now, we need to figure out how many clusters will give us the optimal results. One of the limitations of k-means is that you have to tell it upfront how many groups you want. But instead of just guessing, we can use a couple of methods to guide our choice. Here, I'll be testing values of k through 2 through 8 and recording 2 metrics for each run. The first being inertia, which measures how close each point is to its assigned cluster center. You can think of it as the total within cluster distance. Smaller inertia means that the clusters are tighter and points are grouped closely around their centroid. But the catch here is that inertia always goes down as you add more clusters. If we set k equal to the number of data points, inertia would be 0. That's why we use something called the elbow method. We look for the point where inertia stops dropping dramatically and starts to level off, forming an elbow in the curve. That's usually a good sign of the right number of clusters. The second metric we'll touch on is the silhouette score. This tells us not just how compact clusters are, but also how separated they are from each other. It ranges from -1 to 1, where higher values mean points are well matched to their own cluster and far from other clusters. A score near 0 means clusters are overlapping, and negative values mean points might actually be in the wrong cluster. So inside the loop, we'll run k-means for each k, collect both inertia and silhouette scores, and then plot them. By combining the elbow method with a silhouette score, we can get a more reliable way to pick k. We want the elbow in the inertia curve and the peak in the silhouette score to line up. That gives us confidence that our choice of k isn't just arbitrary, meaning it's backed by evidence from 2 different perspectives. Let's run our code. Looking at the inertia curve, we watch for the point where the line bends or forms an elbow. And with the silhouette score, we will look for the peak, that being the k value where the clusters are most distinct. We check which k has the best silhouette score, and we save it as best k. In this dataset, both methods suggest that 5 clusters is a really good choice. That gives us a balance between compact clusters and clear separation. Now that we know how many clusters to use, we can actually fit our k-means model. Here, I'm setting k equal to the best number of clusters we found earlier, that being 5. You could also set it manually, for example, to 6 or 7. Next, I create a k-means model with that number of clusters. I've set n in it equal to 10, which means the algorithm will run 10 times with different random starting points and keep the best result. This helps make sure we don't get stuck with a bad initialization. I also set random state equal to 42, so the results are reproducible. If you or I run this again, we'll get the same clusters. I'll then call fitPredict on the scaled data. This both fits the model and assigns each customer to one of the clusters, giving us a set of cluster labels. Finally, I'll add those labels back to a copy of our original dataset as a new column called cluster. Now, every customer is not just a point in the dataset. They also belong to a specific group found by k-means. Let's take a quick look at the first rows to see how that looks. Now, let's visualize the clusters k-means found. First, I'll create a scatter plot where each point is a customer, and I color them according to which cluster they belong to. The x-axis is annual income, and the y-axis is spending score. That way, we can see how customers are grouped based on these 2 features. Next, I plot the centroids, which are the centers of each cluster. Because k-means was run on scaled data, I convert the centroids back into the original units of income and spending so they line up with our plot. I make them large star markers with a black outline so they stand out clearly from the customer points. Finally, I add axes labels, a title showing the number of clusters, and a legend, so it's clear which color corresponds to which cluster. When you look at the finished chart, you can actually see how k-means has separated customers into distinct groups, each with its own centroid representing the average customer for that cluster. This is a great way to confirm that the algorithm has indeed found meaningful patterns within the data. Now that every customer has been assigned to a cluster, let's summarize what each cluster looks like. Here, I'm grouping the data by the cluster label and then calculating 3 things for each group: the count, or how many customers are in that specific cluster, the average income of customers in that cluster, and the average spending score for that cluster. This gives us a simple profile for each cluster. Instead of just seeing colors on a chart, we now have concrete numbers that describe each group. For example, we can see which clusters represent high-income big spenders, which ones are budget-conscious, and which ones fall somewhere in between. These profiles are really valuable in practice because they turn raw clusters into insights that a business can actually use. For example, identifying your most valuable customer segment or spawning groups with untapped potential. Let's break down the 5 customer segments we found. Cluster 0 is the largest group. These customers have mid-level incomes and average spending habits. They're not overspending, but they're also not on the low end. You can think of them as your middle ground steady customers. Cluster 1 is high income and also high spending. These are your premium or big spenders. They're very valuable customers because they both have the ability and the willingness to spend. Cluster 2 is a bit more interesting. They have lower incomes, but they spend a lot relative to what they make. These could be aspirational shoppers or highly loyal customers who prioritize shopping despite having less income. Cluster 3 is the opposite: higher income but very low spending. They can afford more, but they choose not to. You can think of them as frugal, wealthy customers or savers. Cluster 4 has both low income and low spending. This is a budget-conscious group, limited in both ability and willingness to spend. So in one run of k-means, we've gone from a cloud of points to clear customer segments, each with different behaviors that a business can target in different ways. One of the coolest parts about k-means is that it doesn't happen all at once. It's iterative. The algorithm starts with random centroids, assigns points to the closest centroid, then shifts the centroids to the mean of their assigned points. It repeats this until things stop changing. To make this more visual, I've created a manual implementation that saves a snapshot at each iteration and stitched them together into a GIF. You'll see how the clusters stabilize over time. This GIF shows how k-means clustering works step by step. At the start, the centroids, the black stars, are placed in random positions. In the first iteration, each customer is assigned to the nearest centroid, forming rough groups. Then, the centroids move to the average position of the points in their cluster. This process of assigning points and updating centroids repeats until the centroids stop moving. What you're seeing is the cluster is gradually stabilizing, with the centroids shifting less and less each round until the groups settle into their final positions. And that's it. We just built our very first unsupervised learning model using k-means clustering. We took a raw dataset, exported it, and chose the right number of clusters, and then watched the algorithm group customers into meaningful segments. Hopefully you can see how powerful even a simple clustering model can be when it comes to uncovering patterns that aren't obvious at first glance. If you found this helpful, I'd really appreciate it if you gave the video a like. It helps more people discover this kind of content. Drop a comment if you have any questions or if there's another topic you'd like for me to cover next. And if you know someone else who's getting into data science, feel free to share this with them so they can follow along too. Most importantly, make sure to hit subscribe so you don't miss the next video in this unsupervised learning series. I'm going to keep building these guides step by step so you can grow your skills right alongside me.